Dynatrace, Guide for Software Engineers, Introduction. Dynatrace is an observability and monitoring platform used to understand application performance, infrastructure health, logs, metrics, traces, user experience, cloud environments, Kubernetes, and production problems. Software engineers use Dynatrace for application monitoring, Spring Boot monitoring, Java service monitoring, Kubernetes monitoring, cloud-native observability, distributed tracing, logs and metrics, error tracking, service dependency mapping, performance troubleshooting, root cause analysis, alerting, dashboards, production incident, debugging. A common learning topic is, how can software engineers understand and use Dynatrace in real-world applications? This guide explains, Dynatrace basics, OneAgent, services, process groups, hosts, Kubernetes monitoring, Spring Boot monitoring, logs, metrics, traces, dashboards, alerts, Davis AI, OpenTelemetry, cloud-native use cases, troubleshooting, interview questions, 30-day learning plan. Dynatrace describes its platform as combining observability, AI, automation, and application security in one platform. Simple definition. Dynatrace is a production monitoring platform that helps teams see what is happening inside applications, infrastructure, Kubernetes, databases, APIs, and user journeys. Simple flow. User opens application. Run. Frontend calls backend API. Backend calls database, cache, queue. Dynatrace collects telemetry. Dynatrace shows problems, traces, metrics, logs, and root cause. Cloud native example. React frontend. Spring Boot API. PostgreSQL. Kubernetes. Dynatrace observability. Why software engineers use Dynatrace. Dynatrace helps answer production questions like: Question: why is the API slow? Which service is failing? Which database query is slow? Which Kubernetes pod restarted? Which deployment caused the issue? Which users are affected? Is the problem front-end, back-end, database, or infrastructure? What changed before the incident? Without observers. User says app is slow. Developer checks logs manually. Team guesses the issue. Incident takes longer. With Dynatrace. Dynatrace detects anomaly, shows impacted service, shows slow request trace, shows database API dependency, helps identify root cause faster. Dynatrace core concepts. Concept meaning: OneAgent, agent installed to collect telemetry automatically. Service, application service detected by Dynatrace. Process group, group of similar running processes. Host, server VM node where app runs. Trace, end-to-end request path. Span, one operation inside a trace. Measurement over time. Log application system event record. Dashboard, visual monitoring screen. Problem, Dynatrace detected issue. Alert notification when something is wrong. Davis AI, Dynatrace AI engine for analysis. Grail, Dynatrace data lakehouse. Query storage platform. DQL, Dynatrace query language. Overview. Application infrastructure. OneAgent, OpenTelemetry. Dynatrace platform. Metrics, plus logs, plus traces, plus events. Dashboards, plus problems, plus alerts, plus root cause. Kubernetes example. Kubernetes cluster. Dynatrace operator. OneAgent, ActiveGate. Dynatrace. Cluster, workload, pod, service, trace, log visibility. Dynatrace Kubernetes documentation says Dynatrace provides real-time insights and health for Kubernetes clusters and workloads. Step 1. Understand observability. Observability means understanding system behavior using telemetry. Main telemetry signals: HAC, logs, metrics, traces, events. Simple idea. Logs tell what happened. Metrics tell how often or how much. Traces tell where a request went. Events tell what changed. Example. End. Metric. API latency increased. Log. Database timeout error. Trace. Request spent 3 seconds in product service. Event. New deployment happened 5 minutes ago. Step 2. Understand OneAgent. OneAgent is Dynatrace's agent installed on hosts, VMs, or Kubernetes nodes to automatically collect telemetry. OneAgent can help collect host metrics, process metrics, service detection, distributed traces, code-level insights, logs, infrastructure data, application dependencies. Simple idea. Install OneAgent. Dynatrace automatically discovers hosts, processes, services, and dependencies. Dynatrace documentation lists technology support for OneAgent and supported platforms, including supported Linux distributions and CPU architectures. Step 3. Understand services. A service in Dynatrace usually represents a backend application, API, or detected service endpoint. Examples: order service, payment service, inventory service, user service, notification service. Dynatrace can show check request count, check response time, check failure rate, check slowest requests, dependencies, database calls, external API calls, exceptions, traces. Example service view. Order service, response time 350 milliseconds, failure rate 2.5%, throughput 500 requests per minute. Calls payment service, calls PostgreSQL, runs on Kubernetes pods. Step 4. Understand process groups. Process group means a group of similar application processes. Example: order service JVM process, order service JVM process, order service JVM process. Dynatrace groups them as ... Process group, order service. Useful for scaling analysis, JVM memory monitoring, CPU usage, restart detection, deployment comparison, process-level troubleshooting. Step 5. Understand hosts. Host means the server, VM, or node where applications run. Dynatrace host view can show CPU, memory, disk, network, processes, host health, availability, infrastructure problems. Kubernetes example. Kubernetes node equals host pod process equals process Spring Boot API equals service. Step 6. Understand distributed tracing. Distributed tracing tracks one request across many services. Example: frontend, API gateway, order service, payment service, database. A trace helps answer: where did the request spend time? Which service failed? Which dependency was slow? Dynatrace documentation explains distributed tracing setup and trace data collection using OneAgent or OpenTelemetry. Step 7. Trace example. Request. Post, API, orders. Trace. Post, API, orders. 40 milliseconds. API gateway. 120 milliseconds. Order service. 900 milliseconds. Payment service. 1500 milliseconds. External payment provider. Conclusion: order API is slow because external payment provider is slow. This is why distributed tracing is powerful. Step 8. Understand metrics. Metrics are numeric values over time. Examples: CPU usage equals 75%. Memory usage equals 2.4 gigabytes. API response time equals 350 milliseconds. Error rate equals 3%. Request count equals 1200 per minute. Database latency equals 800 milliseconds. Use metrics for dashboards, alerts, trend analysis, capacity planning, SLA/SLO monitoring. Step 9. Understand logs. Logs are event records. Example: Spring Boot log. 2026-06-09, 10/30/22, error, order service, payment failed for order ID equals 123. Logs help answer: what error happened? When did it happen? Which user order request was affected? Which exception was thrown? What did the application do? Dynatrace supports connecting log data to traces through log enrichment, including configuration through OneAgent features. Step 10. Logs plus traces together. Best production debugging. Trace shows slow request. Log shows exception. Metric shows error spike. Deployment event shows new version. Root cause becomes clear. Example. Trace. API orders took 5 seconds. Log. Connection timeout to PostgreSQL. Metric. DB latency increased. Event. Database node CPU reached 95%. Step 11. Dynatrace with Spring Boot. Spring Boot applications are commonly monitored with Dynatrace. Dynatrace can help monitor REST endpoints, JVM metrics, garbage collection, exceptions, database calls, external API calls, response time, failure rate, service dependencies, Kubernetes pod behavior. Example Spring Boot app. Order controller, order service, order repository, PostgreSQL, Dynatrace, view. Order service, PostgreSQL dependency, slow query detected. Dynatrace OneAgent release notes currently mention support for Spring Boot 4.0 and Spring Framework 7.0 versions in OneAgent 1.333. Step 12. Spring Boot Actuator plus Dynatrace. Spring Boot Actuator exposes operational endpoints. Common endpoints. Get actuator health. Get actuator metrics. Get actuator info. Example configuration. Management endpoints. Web exposure include health info metrics endpoint. Health. Show details when authorized. Important. Do not expose sensitive actuator endpoints publicly. Use actuator with Dynatrace for health checks, custom metrics, application metadata, readiness, liveness signals. Step 13. Add custom logs in Spring Boot. Good structured log. At SL4J, at service, public class, order service. Public order response, create order request. Log.info. Creating order for user ID ... product ID ... request.user ID, request.product ID. Try. Business logic. Log info, order created successfully, user ID equals request.user ID. Catch exception X. Log error. Order creation failed, user ID, product ID equals request.user ID, product ID equals throw X. Return new order response. Good logs include check, action, check, business ID, correlation ID, error details, no sensitive data. Avoid logging. Next, passwords, access tokens, refresh tokens, full credit card data, private personal data. Step 14. Correlation ID. Correlation ID connects logs and traces. Flow. Frontend sends X correlation ID. Spring Boot receives request. Logs include correlation ID. Dynatrace trace, log search becomes easier. Spring Boot filter. Component, public class correlation ID filter, extends once per request filter. Private static final string header equals X correlation ID. Override, protected void do filter internal, HTTP servlet request, HTTP servlet response, filter chain, through servlet exception, IO exception. String correlation ID equals request.getHeader. If correlation ID equals null or correlation ID.is blank. Correlation ID equals uuid.randomuid to string. MDC.put correlation ID, response.setHeader, header, correlation ID. Try. Filter chain do filter, request, response. Finally, MDC.remove correlation ID. Logback pattern example. Pattern DD YYY MMDD HHMMSS %5 level correlation ID equals X correlation ID %logger %MSG in panel. Step 15. Dynatrace with Kubernetes. Dynatrace is widely used in Kubernetes environments. It can monitor clusters, nodes, namespaces, workloads, deployments, pods, containers, services, events, resource usage, restarts, traces from apps running in pods. Dynatrace Kubernetes deployment documentation says deployment options for Kubernetes observability. Leverage Dynatrace operator. Step 16. Kubernetes monitoring view. Example. Cluster, production cluster. Namespace. order platform, deployment, order service, pods, 5 running, restarts, 2, CPU, 70%, memory, 80%, and service response time, 400 MSS. Use Dynatrace Kubernetes monitoring to answer. Question: which pod restarted? Which node is under pressure? Which deployment caused failures? Which namespace has high CPU? Which service is slow? Which container is crashing? Step 17. Dynatrace with OpenTelemetry. OpenTelemetry is an open standard for collecting telemetry like traces, metrics, and logs. Dynatrace supports OpenTelemetry ingestion and has Java walkthroughs for adding observability using OpenTelemetry Java libraries and tools. Architecture: Java, Node, Python app, OpenTelemetry SDK or agent, OTLP export, Dynatrace, traces plus metrics plus logs. Use OpenTelemetry when: check, you want vendor-neutral instrumentation. You already use OpenTelemetry. You need custom spans. You have polyglot microservices. You want standard trace context propagation. Dynatrace documentation also says it supports sending AI observability data through OTLP API endpoints. Step 18. Java OpenTelemetry example. Run Java app with OpenTelemetry Java agent. Java agent OpenTelemetry Java agent.jar. .tel.service name order service. .tel.exporter.otlp endpoint. https:/your Dynatrace endpoint. jar order service.jar. Concept: Java app emits traces. OpenTelemetry exports telemetry. Dynatrace receives and analyzes it. OpenTelemetry Java automatic instrumentation can be used through the OpenTelemetry Java agent. Step 19. Dynatrace dashboards. Dashboards show key system health. Useful dashboard sections. Check: service health, API latency, error rate, throughput, Kubernetes pod restarts, CPU memory usage, database latency, log error count, deployment changes, user experience. Example dashboard. Production order platform dashboard. 1. API response time. 2. API failure rate. 3. Throughput. 4. JVM memory. 5. Kubernetes pod restarts. 6. PostgreSQL latency. 7. Top errors. 8. Recent deployments. Step 20. Important metrics to watch. Application metrics. Response time. Request count. Failure rate. Exception count. Slowest endpoints. JVM metrics. Heap memory. Non-heap memory. Garbage collection time. Thread count, CPU usage, Kubernetes metrics, pod restarts, CPU requests limits, memory requests limits, pressure, container crashes, database metrics, query time, connection pool usage, deadlocks, slow queries, database CPU. Step 21. Dynatrace problems. A Dynatrace problem is a detected issue or abnormal behavior. Examples: response time degradation, failure rate increase, service unavailable, CPU saturation, memory pressure, pod crash loop, database slowdown. Problem view can help show impacted entities, root cause candidate, timeline, related events, dependencies, affected users' sources.
Step 22. Davis AI.
Davis AI is Dynatrace's AI engine. It helps with: check, anomaly detection, check, root cause analysis, check, alert noise reduction, check, dependency-aware problem analysis. Dynatrace markets its platform around observability with AI and automation, and independent reviews also highlight Davis AI for anomaly detection and root cause analysis in enterprise observability contexts. Simple idea: traditional monitoring, CPU under 90%, send alert. Dynatrace, response time increased because payment service is waiting on external API. Step 23. Alerting. Alerts notify teams when something needs attention. Good alert examples: API failure rate greater than 5% for 5 minutes. P95 latency greater than 2 seconds for 10 minutes. Pod restart count increased suddenly. Database connection pool exhausted. Payment error rate increased. Bad alerts. Alert on every tiny warning. Alert without business impact. Alert without ownership. Alert without runbook. Good alert should include what happened, affected service, severity, impact, dashboard link, owner team, runbook. Step 24. Service level objectives. SLO means target reliability level for a service. Example, 99.9% of checkout requests should complete successfully within 2 seconds. Useful SLOs. COC, availability, COC, latency, COC, error rate, COC, successful transactions. Example, order API SLO, 99.5% requests under 500 milliseconds. Error rate below 1%. Step 25. Real user monitoring. Real user monitoring means monitoring real users' browser app experience. It can track. Check. Page load time. Check. Front-end errors. Check. User sessions. Check. Browser type. Check. Location. Check. Slow pages. Check. API calls from browser. Use cases. Users in Toronto report slowness. Dynatrace shows front-end page load issue from CDN or API latency. Step 26. Synthetic monitoring means running automated checks to simulate user actions. Examples. Check. Open homepage. Check. Login. Check. Search product. Call API endpoint. Checkout flow. Use synthetic checks for, uptime monitoring, critical journey testing, API availability, pre-user impact detection. Example. Every 5 minutes. Open login page. Submit test login. Check dashboard loads. Alert if failed. Step 27. Dynatrace for microservices. Microservice architecture. API, gateway, down, order service, payment service, inventory service, notification service. Dynatrace helps with service dependency map, distributed traces, failure rate per service, slow dependency detection, deployment impact, Kubernetes pod mapping, root cause analysis. Example, order API is slow. Dynatrace trace shows payment service is slow. Payment service trace shows external gateway latency. Step 28. Dynatrace for database troubleshooting. Database problems Dynatrace can help identify. Slow queries, high query count, connection pool exhaustion, database dependency latency, service waiting on database, spikes after deployment. Example, API products latency increased. Trace shows product repository.findAll. Database query takes 4 seconds. Root cause, missing index. Spring Boot fix idea. Public interface product repository extends JPA repository product long. List product find by category ID, long category ID. Database fix idea. Create index, IDX product category ID, on product category ID. Step 29. Dynatrace for JVM troubleshooting. Java Spring Boot problems. COC, high heap usage, memory leak, frequent garbage collection, thread pool exhaustion, CPU spike, slow controller, exception increase, dependency timeout. Example, JVM heap keeps increasing. GC time increases. Response time increases. Dynatrace shows memory pressure. Possible causes. Check, memory leak, large cache, unbounded collection, too many objects, bad batch processing. Step 30. Dynatrace for deployment analysis. After deployment, watch. Error rate, response time, throughput, new exceptions, CPU memory changes, pod restarts, database latency, user impact. Deployment troubleshooting flow. Deployment happened at 10 a.m. Error rate increased at 10:05 a.m. New exception appears in logs. Trace points to changed API. Rollback or fix. Step 31. Real-world troubleshooting scenario. Users report. Checkout is slow. Dynatrace investigation. 1. Open checkout service. 2. Check response time. 3. View slow traces. 4. Identify dependency. 5. Check payment service. 6. Check logs. 7. Check deployment events. 8. Check Kubernetes pod restarts. 9. Confirm root cause. Finding. Payment service external API call timeout increased from 200 milliseconds to 3 seconds. Set timeout. Add circuit breaker. Retry carefully. Add fallback. Contact provider. Improve alert. Step 32. Real-world project. Dynatrace monitoring for Spring Boot order platform. Architecture. React frontend. Spring Boot order API. PostgreSQL. Redis. Kafka. Kubernetes. Dynatrace. Monitoring requirements. Check. Monitor front-end user experience. Monitor Spring Boot APIs. Monitor JVM. Monitor PostgreSQL dependency. Monitor Redis dependency. Monitor Kafka consumer lag errors. Monitor Kubernetes pods. Collect logs. Create dashboard. Configure alerts. Trace order flow. Step 33. Recommended dashboard for project. Dashboard title. Order Platform Production Health. Widgets. 1. Order API response time. 2. Order API failure rate. 3. Request throughput. 4. P95 latency. 5. JVM heap usage. 6. Pod restart count. 7. PostgreSQL query latency. 8. Redis latency. 9. Kafka processing errors. 10. Top exceptions. 11. Recent deployments. 12. Active problems. Step 34. Dynatrace Learning Roadmap, beginner level. Learn. Observability basics. Logs. Metrics. Traces. Services. Hosts. Dashboards. Problems. Build. Monitor one Spring Boot app. Intermediate level. Learn. Search. Distributed tracing. Kubernetes monitoring. Kubernetes database monitoring, alerting, log enrichment, correlation ID. Build. Monitor Spring Boot plus PostgreSQL on Kubernetes. Advanced level. Learn. Cur OpenTelemetry integration. Custom metrics. DQL. SLOs. Automation. Root cause analysis. Multi-service troubleshooting. Build. Monitor full microservices platform. Common beginner mistakes. 1. Thinking Dynatrace is only logs. Bad understanding. Dynatrace equals log viewer. Better. Dynatrace equals observability platform for logs, metrics, traces, infrastructure, services, users, and dependencies. 2. Not using correlation IDs. Problem. Front-end error, back-end log, and database issue are hard to connect. Better. Use trace context and correlation IDs. 3. Too many alerts. Bad. Alert on every small warning. Better. Alert on user impact and critical service health. 4. Ignoring Kubernetes context. Bad. Only check application logs. Better. Also check pod restarts, node pressure, resource limits, and deployment events. 5. Not checking deployment events. Many incidents happen after deployment. Always check what changed recently. 6. Logging sensitive data. Bad. Logging JWT tokens, passwords, personal data, or secrets. Better. Log safe business IDs and correlation IDs. Best practices. Check, monitor front-end and back-end. Use distributed tracing. Connect logs to traces. Use correlation IDs. Monitor Kubernetes workloads. Monitor JVM and database metrics. Create service-specific dashboards. Alert on business impact. Reduce noisy alerts. Check deployment events during incidents. Protect sensitive data in logs. Use OpenTelemetry where useful. Create runbooks for common problems. Define SLOs for critical APIs. Review top errors regularly. Monitor external dependencies. Dynatrace interview questions. 1. What is Dynatrace? Dynatrace is an observability platform used to monitor applications, infrastructure, Kubernetes, logs, metrics, traces, user experience, and production problems. 2. What is OneAgent? OneAgent is Dynatrace's agent installed on hosts or Kubernetes environments to automatically collect telemetry and discover services, processes, hosts, and dependencies. 3. What is distributed tracing? Distributed tracing tracks one request across multiple services to show where time is spent and where failures occur. 4. What are metrics, logs, and traces? Metrics are numeric measurements. Logs are event records. Traces show request flow across services. 5. What is a Dynatrace problem? A problem is an issue detected by Dynatrace, such as response time degradation, failure rate increase, unavailable service, or resource saturation. 6. What is Davis AI? Davis AI is Dynatrace's AI engine used for anomaly detection, root cause analysis, and impact analysis. 7. How does Dynatrace help with Spring Boot? Dynatrace can monitor Spring Boot endpoints, JVM metrics, database calls, exceptions, service dependencies, traces, and Kubernetes runtime behavior. 8. How does Dynatrace help with Kubernetes? Dynatrace can monitor clusters, nodes, namespaces, workloads, pods, containers, services, events, resource usage, and application traces. 9. What is OpenTelemetry? OpenTelemetry is an open standard for collecting telemetry, such as traces, metrics, and logs. Dynatrace supports OpenTelemetry ingestion for Java and other applications. 10. How do you troubleshoot a slow API in Dynatrace? Steps. 1. Open service 2. Check response time and failure rate. 3. Open distributed traces. 4. Identify slow span dependency. 5. Check logs. 6. Check Kubernetes resource metrics. 7. Check deployment events. 8. Confirm root cause. 11. What should you monitor for a Java service? Monitor. Check response time. Check error rate. Check throughput. Check JVM heap. Check garbage collection. Check CPU. Check threads. Database calls. Check external API calls. Check exceptions. 12. What should you monitor in Kubernetes? Monitor. Cook. Pod restarts. Cook. CPU memory usage. Cook. Node health. Cook. Workload health. Cook. Deployment events. Cook. Container crashes. Cook. Resource limits. Cook. Namespace health. 30-day learning plan week 1. Observability basics. Learn. Check logs, metrics, traces, services, hosts, dashboards, alerts. Practice. Understand one application dashboard. Week 2. Spring Boot monitoring. Learn. Check service response time. Check failure rate. Check JVM metrics. Check exceptions. Check database calls. Check actuator basics. Practice. Monitor 1 Spring Boot REST API. Week 3. Kubernetes and Cloud Native. Learn. Kubernetes cluster monitoring. Kubernetes containers. Kubernetes restarts. Resource limits. Kubernetes deployment events. Practice. Deploy Spring Boot app to Kubernetes and monitor it. Week 4. Advanced troubleshooting. Learn. Distributed tracing. Log enrichment. Correlation ID. OpenTelemetry. SLOs. Root cause analysis. Alert tuning. Practice. Simulate slow API, database failure, pod restart, and bad deployment. Real-world hands-on practice. Practice 1. Slow API. Create an endpoint. Get mapping. Slow, public string slow API. Throws interrupted exception. Thread.sleep 3000. Return slow response. Observe. Current, response time increase, slow trace, service latency. Practice 2. Exception spike. Create endpoint. Get mapping /error. Public string error API. Throw new runtime exception. Test exception. Observe. Failure rate. Exception details. Logs. Problem detection. Practice 3. Database slowness. Create slow query or missing index scenario. Observe. Database dependency latency. Slow request trace. Affected endpoint. Practice 4. Pod restart. Restart Kubernetes pod. kubectl, delete pod, pod name. Observe. Check pod restart. Check workload health. Check events. Service impact. Final summary. Dynatrace is a powerful observability platform for modern software systems. Important concepts include OneAgent, services, process groups, hosts, logs, metrics, traces, distributed tracing, dashboards, alerts, Davis AI, Kubernetes monitoring, Spring Boot monitoring, JVM monitoring, OpenTelemetry, SLOs, root cause analysis. Software engineers use Dynatrace to answer what is broken, who is affected, where is the failure, why did it happen, what changed recently. Key idea. Dynatrace helps developers and operations teams monitor, troubleshoot, and improve cloud-native applications. By connecting application performance, infrastructure, logs, metrics, traces, Kubernetes, and user experience in one observability platform.